Welcome back to another video. Here, we will talk about independence in joint probability distributions. Imagine we have two random variables, x and y. By definition, when we say x and y are independent, we mean that knowing the value of x doesn't tell us anything about y, and vice versa. They are completely separate, like two strangers who don't interact. Here are the key ideas about independence. 1. The behavior of both x and y together, their joint distribution, is just the product of how they behave individually. This means the two variables don't influence each other in any way. This also means that the domains of x and y needs to be separate. 2. When you look at one variable while knowing the value of the other, conditional distribution, independence means the first variable is unaffected by the second. For example, if you know the value of x, it doesn't change your expectations about y. Similarly, knowing y doesn't change your expectations about x. 3. If you focus on certain events or ranges for x and y, like x being in a specific range and y being in another, independence means the probability of both events happening together is simply the product of their individual probabilities. In other words, they occur independently of each other. Let's go over an example together. Here we are given a joint probability distribution for positive random variables x and y, and we need to decide whether x and y are independent and find the joint probability of x being greater than 1,000 and y being less than 1,000. You can pause the video here and take a moment to answer these questions. To answer the first question, we can check whether their joint distribution is just the product of the marginal distributions for all values x and y. To do so, we start by finding the marginal distributions of x and y. The marginal distribution of x can be found by integrating the joint distribution with respect to y, and similarly, the marginal distribution of y can be found by integrating the joint distribution with respect to x. We can confirm that the product of the marginal distributions gives us the joint distribution over the independent domains of x and y, and as a result, we can conclude that x and y are independent. To find the joint probability of x being greater than 1,000 and y being less than 1,000, instead of doing a double integration, we can multiply the probability of x being greater than 1,000 and probability of y being less than 1,000, as we just proved x and y are independent. Thank you for listening to this short lecture on independence in joint probability distributions.